Parameters in statistics are characteristics of whatever population or sample, as the case may be, that we're looking at. So parameter is the word that goes with population, and statistic is the word that goes with sample. So parameter is any characteristic of a population, which, remember, the population is everybody we care about, as all of the population. Statistics are those same characteristics but of the sample. Which, again, the sample's the ones we actually look at. Population's everyone they care about. This characteristic could be anything. It could be the mean, which we haven't talked about mean yet, but mean, median, mode. It could be standard deviation, variance. It could be just the general shape, what it all looks like. Since these are kind of hard to type, let me pull out a little drawing program and draw a few of them. So, let's see, here's my pointer. So if it was shape, well, there's different ones it could be. It could be bell shapes. That happens a lot in statistics. Bell shape just means it basically looks like a hump. So you've got most people land somewhere in the middle. You've got some at the top, some at the bottom, but the bulk is in the middle. You could have left skewed. Left skewed means just the left-hand tail is bigger than the right-hand tail, so it looks something like this. Or same thing, you could have right skewed. And I would continue to not spell skewed right. So skewed would just mean the right tail is longer than the left tail. These are all sorts of different shapes you can have, and again, that shape is just one example of a characteristic of your population or characteristic of your sample. Let me pull out another one. Again, we haven't actually talked about mean, median, and mode yet, but the mean of the population, well, mean just means average, so add up all the numbers, divide by how many there are. The main thing I want to say about this now is just to let you know that in this class, if you see Greek letters, that's talking about the population. If you see Roman letters, which is just regular English letters, then you're talking about the sample. So mean is probably a bad one to start out with because for sample, the symbol's a little strange. So mean of the population, well, mean starts with the letter M. The Greek equivalent of the letter M is the letter mu, so it's mu. For sample, for some reason, it's X bar. I don't know, they just picked that. Standard deviation, which again, we haven't went over, but we'll go over them soon enough. Well, standard starts with the letter S, so the sample one is the letter S. The population one, well, the Greek equivalent of the letter S is the letter sigma, so it's a lowercase sigma. One that's quite a ways away, but we'll throw it up there. Correlation coefficient. The sample one, well, is the letter R. No particularly compelling reason you can give real quick. But the Greek equivalent of the letter R is the letter rho, so it's rho. Anyway, the reason I say this is just because we'll have a lot of formulas later on in this class, and students always get confused. What's the difference between the mu mean and the X bar mean? It's just, oh, if you see mu, that's supposed to be the whole population. If you see X bar, that's just the sample. Same thing. Sigma is the whole population standard deviation. S is just the sample standard deviation, and so on and so forth. Alrighty.